Good morning, everyone, and today, or hello, everyone, rather. And today we're looking at another really important topic for being able to secure a top grade at GCSE, and that is composite functions. Okay, now a composite function is when a function goes into a function. It's basically a function that is kind of like linked to another function. So, for example, if we were to use the illustration of function machines, going back to Key Stage 2, so if we have one function g of x, and let's say the input is x goes into it, then what comes out is going to be that function of x. And then let's imagine that g of x goes into another function called f of x. Then the output that comes out if g of x goes into f of x is f of g of x. Okay, so that's how we would write it. This is our composite function. So x goes into g of x comes out, and then g of x goes in turn into f of x, so that what comes out is f of g of x. Now, when I'm thinking about this, the way that helps me to remember this is the one that happened first, the g of x, is the one that's closest to the x in brackets. And that we call the inner function, the one that happened first. The one that's furthest away on the outside is called the outer function. Okay, so that's going to be a really useful idea for getting to grips with this topic. And that is a really useful idea as well for when you're thinking about this topic at A level as well. Actually, yes, because this topic is relevant to both A level and GCSE. So let's imagine now that the functions happened the other way around. So in other words, the f of x happened first, and it then went into g of x after it had gone into f of x. Now this time, what's going to come out is g of f of x. And notice that the g and f have swapped places now, okay? So the f is now the one that is closest to the x in brackets because it's the one that happened first, okay? So that's now our inner function because it happened first, and our outer function is now the g of x. That little idea there is the key to understanding the topic of composite functions. Okay, so let's have a look at we'll look at a straightforward example in this video, and then perhaps in the next video we'll look at some slightly more complicated ones. So just as our introduction, first of all, let's do it with numbers. Okay, so what we've got is we're going to look at question A here, where our f of x is 10 minus x, and our g of x is x squared. Okay. And the first one, part one, it wants us to find out g of f of 8. Oops, of 8. G of f of 8. Okay, so let's work out then. I'm going to put g, and I'm going to put open brackets, and this function is now inside this function. So I'm going to work out what f of 8 is. And what is the function f of x? It is 10 minus x. So I'm going to write 10 minus 8, because this is the f of x, which is 10 minus x, going into the g of x. So that means I need to work out g of 2 now. So now we look at the function g of x, and g of x is x squared. So I need to work out 2 squared. So my answer to that first one is 4. Okay, so that is our g of f of 8. Part 2. The question now wants us to find f of 2. So I'm going to write down f of x, and in the brackets, we're going to have 2 is going into f of x. And f of x is 10 minus x, so that's going to be 10 minus 2. So I need to work out f of 8. Okay, so f of 8. So now f of x is 10 minus x. So I'm going to have 10 minus 8. So my answer is now 2 for that one. So that is part 2, f of 2. The next one, let's now look at g of f of x. So the first couple have been numerical, just putting numbers in and seeing what answer you get for your number. Now this next one is going to be having some algebra in, so it's going to be algebraic. And this is where, it starts to get a bit more challenging. The first part, most students find parts 1 and 2 okay. It's this part 3 where people get confused. So let's look at this next thing then. So we've now got to work out g of f of x. Okay, g of f of x. So f of x is going into g of x. So I'm going to write down what my f of x is. It is 10 minus x, like so. And now I need to do, this is like the new x, as it were. So I need to work out what g of this is. Because notice the f of x has gone into the g of x. And the g of x is whatever the new x is squared. So we're going to have 10 minus x all squared. And that is our algebraic expression for our g of f of x, okay, with one function going into the other. We'll do one more. We'll do one more. Let's do e, okay, so we're going to do e, and this time these are the sort of like introductory ones. In e, our function f of x is equal to the square root of 3x add 1, and our g of x is equal to 12, this time minus 2x. So the first thing we've got to work out here now is we want to work out g of f of 8. So let's have a look at that. G of f of 8. So we've got g and we've got f of 8, which is going to be the square root of 3 times 8 add 1. So you can see that the g of x has gone, the f of x has gone into the g of x. Well, 3 times 8 is 24. 24 add 1 is 25. And the square root of 25 is 5. So we're just going to write down, we've got to work out g of 5. So now we're going to work out 12 minus 2 times 5. So that's now the answer that came out is going into the g of x. So we've now got to work out 12 minus 2 times 5, and that is going to give us 12 take away 10, so our answer is 2. Okay, so that is our first one done there. That is our E part 1. G of f of 8 is 2. Now part 2. G of x. So g of x is going to go into g of x. So we've got g of whatever g of x is. And g of x is 12 minus 2x. So that's what we're going to be our new input is. That's going to be, as it were, our new x. So let's have a look at this now. We've now got to work out g of that. So, and g of x is 12 minus 2x. So we're going to have 12 minus 2 times our new x. But our new x is 12 minus 2x. Okay, there we go. So we're going to have g of, now we can expand this bracket, so that's 12 minus 2 times 12, that's going to be 24. And minus 2 times minus 2 is plus 4x. Keep on collecting these like terms. Oh, actually, I've put a g of x there in brackets. I didn't need that because this is our answer that we're working out now. Okay, get rid of that. Okay, yeah, so basically, notice our g of x has gone in to the g of x. That's why we didn't need that g of x notation there anymore. Okay, that's fine. So we now just need to collect our like terms, and we've got 4x minus 12 as our answer there for that one. 4x minus 12 is our answer to the second part. And then finally, what does it want us to find? F of g of x. So part 3, we've got to find out now f of g of x, okay? So f of g of x. Now, g of x is now going into our f of x. So we're going to have f of whatever g of x is, and our g of x is 12 minus 2x. So that's going in. So 12 minus 2x is going in. We've now got to work out f of that, and our f of x is the square root of 3x add 1. So we're going to have the square root of 3 times our x, which is 12 minus 2x, add 1 there on the end, add 1 like so. Okay, so we're going to work that out now. So that's going to be 3 times 12, that's going to be 36, and we're going to have minus 2x times by 3, so that is minus 6x, and then we've got add 1 there like that. So we can see what we're going to get here now. Let's see what we're going to get when we work this one out. That's going to be 30, that's square root symbol around that whole thing. 36 add 1 is 37. 37 minus 6x, and the whole thing is square rooted. Okay, and that's our answer for f of g of x. Okay, I hope that you found that useful. That's our introduction to composite functions. I'll make another video now where we just look at ones that are slightly more complicated, where we maybe have a function of a function of a function. And I will see you in the next video.